In October 1957, a metallic sphere no bigger than a beach ball started beeping. From space. That sound, it wasn't just the first artificial satellite, it was the starting pistol for a race that would define the next century. But that little sphere, it wasn't alone for long. Over the next few decades, humanity would launch hundreds of missions beyond Earth, to the moon, to the outer planets, and even into the deep unknown. Some of these missions lasted minutes, others are still going, decades later, drifting silently through interstellar space. But here is the thing, not every mission makes history, and not every spacecraft changes what we know about the universe. But a few, just a few, did. They revealed alien landscapes no one had imagined. They captured images that reshaped how we see ourselves. And in some cases, they left behind messages for whoever or whatever might find them. So today we are going to look at the most important space missions in history. Not just the most expensive, not just the most famous, but the ones that truly changed everything. From the way we explore space to how we understand our place in it. And as we go through, one question will keep coming back. What comes next? Because the missions we'll explore today didn't just happen. They built a foundation for a future that's already arriving. This is the story of how humanity reached for the stars and touched them. And before I roll the intro, I would like to thank all 500 subscribers and counting. This video is a 500 subscribers special. Enjoy! October 4th, 1957. That was the night everything changed. At first, it was just a sound. A faint, steady beep pulsing from low Earth orbit. But to the people tuning in, and especially to the leaders in Washington, that sound hit like a thunderclap. Because it wasn't just static, it was a signal, and it was coming from space. The Soviet Union had just launched Sputnik 1, the world's first artificial satellite. A 23-inch sphere made of polished metal equipped with 4 spindly antennas, and a radio transmitter that let the entire world know it was up there, orbiting and watching. Before Sputnik, space was just an idea, a backdrop for novels, science fiction, and distant dreams. After Sputnik, it was real, tangible, and political. This wasn't just a technological achievement, it was a declaration. The Cold War had gone orbital. The United States, caught flat-footed, scrambled to respond. Funding for science and engineering exploded overnight. Within a year, NASA was born. Telescopes pointed skyward. And the idea of space as the next frontier, that was no longer a metaphor. Sputnik had changed everything, and it didn't even carry a camera. It didn't take photos, it didn't carry experiments. It didn't even last that long, just 3 weeks of transmitting data before a battery died. A few months later, it burned up in Earth's atmosphere. But its impact? That still echoes. Because Sputnik proved it could be done. That we could leave the surface of our planet and enter a realm no human had ever touched. It was the first step on the ladder we are still climbing. And maybe the most incredible part? It wasn't sent by a billionaire, or a tech startup, or a space agency born out of decades of planning. It was launched by a group of engineers in a secret Soviet program in the middle of geopolitical standoff. And somehow they made it work. The space age had begun. Not with a roar, but with a beep, and Earth would never look the same again. Imagine sitting inside a metal capsule the size of a small car. You're strapped into a seat, alone, on top of a rocket designed for war, not safety. You never tested it at full scale. No one has. And the launch countdown just hit 0. That was the reality on April 12, 1961, the day Yuri Gagarin became the first human ever to leave the Earth. His spacecraft was called Vostok 1, and it was unlike anything flown before. A squat, spherical capsule with barely enough room to move. No manual controls, no backup systems, just Gagarin, a pressure suit, and a radio link back to the ground. But it worked. Gagarin's flight lasted just 108 minutes, a single orbit around Earth. But in that time, the world changed again. Because until that moment, space was for machines, for probes, satellites, and mathematical abstractions. But when Gagarin crossed the invisible line into orbit, space became human. And the moment he returned, he was a global sensation. the first representative of our species to go beyond the cradle. But let's not forget, this was no pleasure cruise. Vostok 1 had no way to land gently. Gagarin had to eject at 7 kilometers altitude and parachute down separately from the capsule. The Soviets didn't even announce the flight until he was safely back on the ground. Why? Because they weren't sure it would work. And they weren't the only ones feeling the pressure. The US had been working on their own manned spaceflight program, Project Mercury, but Gagarin beat them by a matter of weeks. The impact was immediate. President Kennedy, under pressure to catch up, soon made a bold promise to land a man on the moon before the decade was out. Vostok 1 didn't just open the door to human spaceflight. It lit a fire under the most ambitious decade of exploration in history. And for Gagarin, he never flew in space again. But he didn't need to. In 108 minutes, he etched his name into history forever. The first human to leave the planet, to see the Earth as a fragile blue sphere floating in the dark, to look out the window and say, "I see Earth. It is beautiful." And he was right. July 20th, 1969. Over 500 million people were watching. Radios were humming, TV screens flickered, and somewhere in the silent black of space, a voice came through.
Houston, Tranquility Base here. The Eagle has landed.
In that moment, humanity did something it had only dreamed of for thousands of years. We landed on the moon. And the craziest part? It almost didn't happen. The mission was called Apollo 11, and it was the culmination of a decade of urgency, politics, engineering, and risk. Thousands of scientists, hundreds of thousands of parts, all leading to a single irreversible moment on the lunar surface. The crew? Neil Armstrong, Buzz Aldrin, and Michael Collins. 3 men trained for every possible scenario, except the one where they wouldn't come home. And make no mistake, that was very much on the table. As Armstrong and Aldrin descended in the lunar module, nicknamed Eagle, they quickly realized something was wrong. The computer was overloaded, the landing site was covered in boulders. Armstrong had to take manual control and pilot the lander himself, with just 17 seconds of fuel left. But they made it. And when Armstrong stepped off the ladder, he didn't just take that one small step. He proved something bigger, that humans could leave Earth, travel nearly 240,000 miles, land on another world, and return safely. The moon, for the first time, had visitors. But Apollo 11 wasn't just about exploration, it was about perspective. When the crew looked back at Earth, they saw something no human has ever seen firsthand. Our planet, alone in the blackness. Fragile, finite, without borders. That view would go on to inspire entire movements, environmentalism, international cooperation, and even a shift in how we think about ourselves as a species. Armstrong and Aldrin spent just over 2 hours walking on the moon, collecting samples, placing instruments, planting a flag, and then they left. But what they left behind wasn't just a footprint. It was a statement that we could do the impossible, that technology and courage mixed with ambition could break every boundary we thought we had. And that maybe, just maybe, we are not meant to stay in one place forever. Apollo 11 wasn't the end of a journey, it was the beginning of a new one. In 1977, NASA launched 2 spacecrafts into the unknown. They were small, fragile, outdated even by the standards of the time. Their computers were weaker than a modern calculator. Their mission? Simple: explore the outer planets. But what happened next, no one expected. Those 2 spacecraft, Voyager 1 and Voyager 2, would become the most successful explorers in human history. Not just visiting planets, but rewriting the books on every world they passed. Voyager 2 launched first, then Voyager 1. Both took advantage of a rare alignment of the outer planets, an event that only happens once every 176 years. Using gravity assist, they could slingshot from one planet to the next without needing massive fuel reserves. And they did. Voyager 1 flew past Jupiter in 1979, capturing the first detailed image of its swirling atmosphere and discovering volcanic activity on its moon Io, the first volcano ever seen beyond Earth. Then came Saturn. Its rings, one thought to be smooth and uniform, turned out to be complex, layered, braided, more intricate than anyone imagined. Voyager 2 followed and went even further. In 1986, it reached Uranus, the first and only spacecraft to ever do so. Then Neptune in 1989, capturing haunting images of its deep blue atmosphere and violent storms. One spacecraft, 4 planets, a tour of the outer solar system that no other mission has matched. But the real magic came after, because the Voyagers kept going. Decades after launch, they both very active, still sending data. In 2012, Voyager 1 became the first human-made object to enter interstellar space, leaving the protective bubble of the Sun's solar wind behind. It's now over 15 billion miles from Earth, and still drifting. Each Voyager carries something else too. The Golden Record, a copper disc with images, sounds and messages from Earth. Greetings in 55 languages, music, laughter, a kiss, a baby crying. It's not just science, it's a message in a bottle, floating through the stars. Will anyone ever find it? Probably not. But that's not the point. Voyager is a proof that we can reach beyond our world, not just with machines but with meaning. That we are not just explorers, we are storytellers. And even if no one hears our message, we still sent it, because somewhere out there the Voyagers are still flying. When the Hubble Space Telescope launched in April 1990, it was supposed to be a triumph, the most powerful telescope ever placed in orbit. Instead, it was a disaster. Just weeks after launch, scientists discovered something horrifying. Hubble's primary mirror, engineered with absolute precision, was flawed, off by just 2 microns. That's less than the width of a human hair. But in astronomy, that's the difference between sharp cosmic vistas and a blurry mess. The media called it a 1.5 billion embarrassment. But NASA wasn't done yet. In 1993, astronauts flew to Hubble on a space shuttle mission to perform emergency repairs in orbit. It was a spacewalk so delicate, one wrong move could ruin everything. They fixed it, and suddenly the universe came into focus. Over the next 3 decades, Hubble would deliver some of the most iconic images in human history. The pillars of creation, the Hubble Deep Field, galaxies in collision, dying stars, forming stars, entire clusters of galaxies caught in a single frame. These weren't just pretty pictures, they were windows into cosmic history. Hubble helped determine the age of the universe, 13.8 billion years. It found that galaxies don't just move, they accelerate, driven by something mysterious, dark energy. It detected atmospheres in exoplanets, witnessed the aftermath of a supernova, and seen comets crash into Jupiter. And through it all, Hubble remained a workhorse, upgraded over 5 separate missions, repaired by hand, an orbiting observatory that somehow kept going. But maybe Hubble's greatest contribution wasn't scientific at all. It was perspective. The Hubble Deep Field, captured in 1995, looked at a tiny patch of sky, just a speck, the size of a grain of sand held at arm's length. In that nothingness, Hubble found thousands of galaxies, billions of stars, trillions of planets. In one image, it made the infinite visible. And that changes you. Because when you see that, you don't just learn about the universe, you feel your place inside it. Hubble didn't just reveal the cosmos, it revealed ourselves. A floating eye circling Earth every 97 minutes, showing us what was always out there, just waiting to be seen. Mars has always called to us, a red dot in the sky, a symbol of war, mystery and alien possibility. We dreamed of visiting it, colonizing it, meeting something. But the reality of Mars? It's harsh. Frozen, dry, airless. Getting there is hard. Landing is harder, surviving almost impossible. And yet we've done it. Not with humans, but with machines. The Mars rovers are some of the most ambitious robotic explorers ever built. Each one a pioneer, each one a survivor. It started with Spirit and Opportunity, twin rovers launched in 2003. Spirit lasted 6 years. And Opportunity? 15. Together, they crossed deserts, climbed hills, survived dust storms, and uncovered a secret hidden beneath the Martian dust. Mars once had water. Not just a little, oceans, rivers, lakes. Long ago, this frozen world may have looked a lot like Earth. Opportunity rolled into a crater and found hematite blueberries, mineral formations that only form in water. Spirit found silica deposits from ancient hot springs. It wasn't speculation anymore, it was evidence. Then came Curiosity in 2012, a nuclear-powered laboratory the size of a small car. It drilled into rocks, found complex organic molecules and radiation levels that could affect future astronauts. Curiosity didn't just look for water, it looked for habitability. Could life have once existed here? The answer is yes, conditions were right, and maybe, just maybe, something lived there once. And then in 2021 came the most advanced rover yet, Perseverance. This one didn't just analyze, it searched for biosignatures, chemical hints of past life. It also began collecting samples that will one day be returned to Earth. Actual Martian rock in human labs. Oh, and one more thing, it brought a friend. Ingenuity. The first powered aircraft flown on another planet. A helicopter flying through thin Martian air. Just a technology demo that's now flown dozens of times. We've gone from 90-day missions to multi-decade exploration. From simple wheels on soil to laboratories on the move. And soon astronauts will follow. But these rovers, they paved the way. They showed us that Mars isn't just a dead world, it's a preserved one. A planet with a past, maybe even a story of life, and we are just beginning to read it. For centuries, Saturn was the most beautiful mystery in the sky, a golden planet wrapped in rings. Distant, cold, untouchable. We'd seen it through telescopes and even flown by it, but we had never truly met it. That changed in 2004. After traveling nearly 7 years and over 2 billion miles, a spacecraft named Cassini entered orbit around Saturn, and everything we thought we knew unraveled. Cassini wasn't just a flyby, it was a long-term guest. For 13 years, it lived in the Saturnian system, orbiting again and again, sending back images and data that no one had imagined. The rings, far more complex than anyone had guessed. Not solid, but made of ice and dust, constantly changing, twisting, rippling from the gravity of passing moons. Speaking of moons, Cassini brought them into focus like never before. Titan, Saturn's largest moon, was a major target. Thick atmosphere, orange haze, a surface hidden for centuries. To see it up close, Cassini carried something special, a lander, the Huygens probe. In 2005, Huygens detached and plunged into Titan's clouds, descending through alien winds and orange fog until it touched down on a solid ground. It was the first and only landing ever made in the outer solar system. And what it saw was otherworldly. Rivers, lakes, even rain, not of water but of liquid methane. A complete active weather system. Titan wasn't just interesting, it was Earth-like in its own strange frozen way. But Cassini wasn't finished. It turned its cameras into Enceladus, a tiny moon barely 300 miles wide. And something was happening there. Cassini saw plumes shooting from the South Pole, gazes of water vapor, ice and organic compounds. A subsurface ocean, heated, salty, potentially habitable. Enceladus of all places became a prime candidate in the search for life. Cassini had rewritten the story of Saturn. But in 2017, it faced a final mission. To avoid contaminating the moons it had discovered, Cassini was directed into Saturn's atmosphere. A final dive. A controlled crash. As it fell, it kept transmitting, collecting data until the very last second. Then, silence. But what Cassini left behind was far from gone. It gave us Saturn's secrets, it gave us new questions, and it gave us a glimpse into just how strange and alive our solar system might be. The Saturn's mystery, it's no longer untouchable. Thanks to Cassini, we touched it. We've sent spacecraft to every planet, we've photographed black holes, we've even landed on comets, but until recently, one destination remained out of reach. Not because of distance, but because of danger. The Sun. It powers life, shapes planets, controls space weather, but getting close to it, that's another story. The Sun's surface is over 5,500 degrees Celsius, but its outer atmosphere, the corona, reaches millions of degrees. It spews radiation, particles, and magnetic storms that can fry electronics, disable satellites, and even threaten astronauts. And yet, in 2018, NASA launched a spacecraft designed to do the unthinkable. Touch the Sun. Its name? The Parker Solar Probe. The first NASA mission ever named after a living person, physicist Eugene Parker, who first proposed the idea of solar wind back in the 1950s. The probe isn't big, roughly the size of a small car, but is the fastest human-made object in history, capable of reaching speeds of over 430,000 miles per hour. To survive, it carries a carbon composite heat shield that can withstand temperatures of nearly 1400 degrees Celsius on one side, while the other side remains cool enough to house instruments and electronics. Its mission? Get closer to the Sun than any spacecraft has ever dared. And it's actually doing it. Each orbit brings it nearer and nearer, deepening into the Sun's outer atmosphere, flying directly through the corona, a place no probe has ever entered. There, it samples the solar wind as its source, measures magnetic fields, and studies energy particles. It's helping scientists answer questions that have puzzled them for decades. Why is the corona hotter than the Sun's surface? How exactly does the solar wind accelerate? And what triggers solar storms that can affect Earth? Already, Parker had delivered surprises. It found magnetic zigzags called the switchbacks, observed dust-free zones close to the Sun, and offered data that's reshaping how we model space weather. But this mission is far from over. Parker will make a total of 24 close passes, each one tightening the orbit. This year it will get within 4 million miles of the solar surface. Closer than Mercury, closer than any dream we once thought possible. It won't last forever. Eventually the Sun will claim it. But until then, Parker is flying, headfirst into the heart of a star. Not just to survive, but to understand. For decades, the Hubble Space Telescope showed us the universe like never before. Galaxies, nebulae, the birth of stars. But there were limits. Places it couldn't see. Light it couldn't catch. We needed something more. Something bigger. Something that could peer further back in time to the very edge of creation. So we built it. The James Webb Space Telescope, a machine so ambitious it almost never completed. A project that took 30 years. Billions of dollars and countless delays. But in December 2021, against all odds, it launched. And it worked, orbiting 1 million miles from Earth. James Webb isn't just another telescope. It's an infrared observatory, designed to see the faint heat of the earliest galaxies, the glow of planets orbiting distant stars, and the light from a time when the universe was still in its infancy. Its mirror, a shimmering gold-plated honeycomb over 21 feet wide, nearly 3 times the size of Hubble's. Its instruments, so sensitive they must be kept at minus 266 degrees Celsius, just a few degrees above absolute zero. Its sun shield, the size of a tennis court, folded up like origami and deployed perfectly in space. Any failure, and there were 344 potential single points of failure, could have doomed the mission. But nothing failed. And what we got was breathtaking. The very first image showed galaxies warped by gravity, light bent by unseen mass, star nurseries lighting up the sky, and faint galaxies formed over 13 billion years ago, when the universe was just a few 100 million years old. Webb has already identified water vapor in the atmospheres of exoplanets. It revealed weather patterns on distant gas giants. And it's just getting started. It's not just about what we see now, it's what we are going to see. Galaxies forming, black holes feeding, potential signs of life. It's the most powerful space observatory ever built. And it was designed not just to extend our vision, but to challenge it. Because every time we've built a better telescope, the universe has surprised us. And Webb? It's not just showing us where we came from, it may help answer the question we've asked all along. Are we alone? The James Webb Space Telescope isn't just looking at the stars. It's looking into our origins, and maybe our future. We've walked on the moon, we've sent robots to Mars, we touched the sun and peered back the beginning of time. But if you think space exploration peaked in the past, think again. The most exciting missions, they haven't happened yet. Right now we are standing at the edge of a new era. One where space isn't just the domain of governments, but a playground for private companies, international coalitions, and explorers with sights set far beyond Earth orbit. Let's start with the Artemis program, NASA's ambitious plan to return humans to the moon. Not for a flag and a photo op, but to stay. build infrastructure, create a base, test the systems we'll need to get the next giant leap. Mars. Artemis 1 launched in 2022 an uncrewed test flight around the moon. Artemis 2 will send the astronauts on a lunar flyby. And Artemis 3? That's the big one. A landing near the moon's south pole, where water ice might support long-term missions. But NASA's not going alone. Enter Starship, SpaceX's fully reusable rocket system, taller than the Saturn V, more powerful than anything ever built, designed to carry 100 tons of cargo or dozens of people. Starship isn't just a rocket, it's a platform for lunar landings, Mars colonization, asteroid mining, and even point-to-point Earth transport. And yes, it's the vehicle that will carry Artemis astronauts down to the moon's surface. And beyond Starship, the horizon just keeps expanding. The Europa Clipper, launched in October 2024, is heading to Jupiter's icy moon, a world with a vast subsurface ocean. It might be one of the best places for search of life. The Nancy Grace Roman telescope will look for exoplanets and dark energy when it launches in 2027. China, India, and the UAE are all ramping up space programs. Private companies building space stations, telescopes that will dwarf James Webb, concepts for nuclear propulsion, fusion engines, and AI-driven probes. And maybe before this century ends, a human footprint on Mars. What used to take decades is now moving in years. The launch pad is crowded, and the sky is no longer the limit. We are not just going back to the moon, we are building the foundation for something bigger, because everything we've done so far, all the missions, all the milestones, have led to this. The future of space exploration isn't a question of if, it's already happening, and we are all part of it. From a tiny metal sphere beeping in orbit, to a rover searching for life on a frozen Martian plain, to a golden telescope looking back to the edge of time. This is what we've done. In just over 60 years, we've gone from crawling off of our planet to reaching to outer planets, to asking questions about our very origins and what else might be out there. Every mission we've talked about wasn't just a success. It was a step, part of a staircase we are still climbing. But here is the thing, we are nowhere near the top. New telescopes are launching, new rockets are flying. New worlds, icy, molten, rocky, ocean-covered, are being found almost every week. And somewhere out there, a Voyager probe is still drifting, carrying a message in a bottle, sailing through the dark. A message that says, we are here, we explored, and we wandered. And we never stopped looking. And if you're watching this, you are a part of this story too. Because space exploration isn't just about rockets and robots. It's about perspective. About what it means to be a small, curious species, staring into the void and choosing to leap. If this video sparked something in you, a memory, a question, a sense of awe, tell us in the comments, which mission changed your view of the universe? And if you want more stories like this, the hidden stories, the untold facts, and the mysteries that science is still trying to solve, make sure to like, subscribe, and hit that bell, because this is Spaceopedia, a place where space mysteries unfold. Thank you for watching, keep looking up.